Hello and welcome. Today I'm going to talk about the AWS Cloud Development Kit, a useful tool for defining cloud infrastructure. So let's say you're building an application and you need some cloud resources. Let's say you want an Amazon S3 bucket. Well, there's a number of ways that you can create this resource for your application. One is you can go into the AWS Web Console, into their GUI, and create a bucket manually that way. Or you can use the command line and use this AWS make bucket command, which is really just calling the make bucket API endpoint. Or you can write CloudFormation in JSON or YAML, and this is a way of defining the bucket using markup. Or you can draw it and create it in Amazon's CloudFormation Designer. Or you can write Terraform to define your bucket. Or you can write Amazon CDK to define your bucket. So what's the difference between these different approaches? Well, one big difference is manual versus infrastructure as code. Now, the creating the bucket manually in the console or with the in the GUI, that's kind of a one-off event. But really, we want to define our infrastructure as code. And why is that? Well, if our infrastructure is defined as code, we can put it in version control. So we can have reviews of it, have all the history of what our infrastructure used to look like, all the great things that come with version control. We can deploy our code, our infrastructure, to different environments. So we can have a dev environment, a production environment. And because our infrastructure is defined as code, it's easy to replicate exactly what we have in the different environments. And you can do a deployment using CloudFormation. And it's not perfectly atomic, but in general, it'll either succeed or fail. And you can always have the option to roll back to the last good known state. And you can also create higher level constructs and reuse them across your projects, either within your application or across other applications if you have certain patterns and certain pieces of infrastructure you find yourself creating often. So CloudFormation is a bit like AWS machine code. It's kind of a foundation layer that describes all the resources that belong in a stack in your account. And there's high-level tools that sort of compile down into CloudFormation, stuff like Terraform, Serverless, CDK. These are all tools that will abstract out some of the details of writing CloudFormation by hand and let you kind of get on with the easier task of describing the resources in some more abstract, succinct fashion. So CloudFormation, like everything else in Amazon, is an API. Kind of the first API that you want to use with it is create stack, and this is a sample call to create stack, and you pass in a template body. This CloudFormation template defines different resources that belong to your stack, and each resource has a type and a set of properties that go with it. Now, when you create a stack, you will have all these resources, and you can see it in the GUI, for example. Here in the web console, you can see the different resources that are created as part of this stack. We can have IAM roles or policies, Lambda functions, databases, DynamoDB, everything. And these resources you can, of course, look up in the documentation, and they have all the different resource types as well as their properties are all documented here. So this is, for example, a couple properties of the S3 bucket. For example, access control. We can set the property whether or not the bucket is public as one of the properties on the S3 bucket resource. Now, CloudFormation itself isn't the greatest thing to work with. It can be very verbose, especially when you're defining things like a Bastion EC2 host or a application that's behind a load balancer or a VPC. It's also just plain markup, so it's hard to kind of reuse and package up into modules with inputs and outputs. It's possible, but it's not very friendly. And the same with writing conditional or logic or anything like that. If you want to have some custom logic where you have different values, depending maybe on the environment that it's in. Again, it is technically possible with CloudFormation, but it's really very limited and not very fun to write. The IDE support isn't great. Like maybe the best you're going to get is some auto completion of properties and types, but it's pretty limited in what it can give you. And you refer to all the different resources by name or by ID. And so if you want to have connections between resources, it can be very hard to see that just with a big pile of markup to see what's connected to what. So fortunately, we have Amazon CDK that we can use to work around some of these limitations. Now, conceptually, a CDK application is made up of one or more stacks, and these correspond to CloudFormation stacks. And these stacks have constructs, which is a grouping of resources, of CloudFormation resources. And you can define this in different languages. You can write it with TypeScript or Java or .NET or Python. And you write it imperatively, and it compiles down into CloudFormation, basically just outputs the resources that you end up defining with this program. Now, there's sort of 3 layers of CDK constructs. And the first layer, the base layer, is just a construct that mimics exactly the CloudFormation resource itself without really any abstraction. And if in TypeScript or Python, for example, this would be some class that has the same properties that your CloudFormation resource has. In layer 2, we have a more convenient API that has sensible defaults, maybe a bit more abstraction, that lets you easily define more complex constructs, sets of resources, everything. And then we can combine those into patterns, what are called layer 3 architectural patterns. And these can be very complex applications or pieces of applications to potentially create any number of CloudFormation resources behind the scenes. So a typical CDK call would look something like this. So here we're creating a S3 bucket in TypeScript and Python and C# and Java. And they all do basically the same thing. You give it a ID, the my bucket there, and then you pass in a list of properties for that bucket. Here's a more complex example. So this is a CloudFormation stack built with CDK that generates a VPC, a virtual private cloud. And this includes, all the subnets and routes and policies, security groups, everything that constructs a VPC. And you can change some of the defaults. It has parameters, but for the most part, the defaults are sensible for what most people need. And you can specify, for example, how many private subnets you want or public subnets, all that kind of good stuff are exposed as kind of high-level knobs. This creates a ECS cluster that we can run basically Docker images in. And this creates a application from a Docker image from Amazon ECS sample there. And it throws it in Fargate and basically runs your Docker image somewhere in Amazon and creates a load balancer and puts it in front of it. There's a reason this is the first functional example that's shown in the documentation. It shows off the power of the high-level constructs. Now, the equivalent CloudFormation template to that is about 500 lines. So if we create these low-level modules and assemble them into more abstract modules and create reusable patterns, we can abstract out a lot of the repetitive and verbose CloudFormation resource primitives that we would normally have to write by hand. So here, all the security groups, load balancer listener, target group, task role, IAM policy, everything else is generated for us just from those few lines of code. Now, if you're lazy like me, this is terrific. But I want to show also a live demo where we can go through creating a CDK stack from scratch and deploy it and see kind of what the process looks like from a code standpoint. I'm going to go ahead and create a project from scratch if you want to follow along here. So I'm going to create a new directory, and we're going to initialize it for a TypeScript project. And so it creates a little skeleton for us. And let's open it up here. So the first thing that we can take a look at is this bin CDK TS. And this is where we define our stack. And to create our stack, we really just create an instance of our stack. And our stack is defined over here in lib. And so right now it's an empty stack, and it looks something like this. Now, in this file, we can actually deploy our stack multiple times. Now, why would you want to do that? Well, maybe you have a dev, stage, production environments, for example, or you want to add some parameters to your stack that customize its deployment. Whatever you want, it's up to you. You can pull in environment variables and use them to control the configuration, or you can hard code it all here. So for example, if you have an application and you know where it should be deployed to, for your company, you can define exactly the AWS account and region for each environment and just hard code that here, which is great. But you can also define, for example, environment variables and use those to control the region and account that it's deployed to if you want to share your stack and let people deploy it anywhere. It's really up to you how you want to manage that kind of stuff. So our stack here, we created an instance of this, and right now it's empty. So let's go ahead and add, let's say, a S3 bucket. So the first thing to know is that all the different areas, all the different APIs or CloudFormation families have different modules on NPM. So I'm going to install the AWS S3 module here, and then we can import that. So I can do import star as S3 from, all right, typing's not so good today. And then if we want to create a S3 bucket, it's as simple as new s3.bucket. And then we pass it the current context. So basically it's parent. So that would be this. And then we give it some name. The name should be unique within the current scope, but it doesn't have to be globally unique. So we could call it like, public bucket. And then we can pass it a list of properties. So for a bucket, one of the properties we have is access control. And then we can say bucket access control dot public, for example. And so what this will do is create us a S3 bucket that lives in our stack, and with this name public bucket and then some prefix to make it unique in the current scope. So taking that, we should be able to do CDK synthesize, and this will compile our little application and output some CloudFormation. So the real thing to notice here is this is our S3 bucket right here that we defined. So you can see that it's got our name public bucket with some suffix, creates a S3 bucket resource with a property access control public read. Pretty cool. And of course, if we want, we can go ahead and deploy this. And in the meantime, we can get a little bit fancier here. So one thing we can do is we can have our stack take some properties. So you can think of it kind of like a React component, for example. We could define CDK stack props, and maybe let's add it like an app name and make it a required string, for example. And then here we're going to inherit from CDK stack props and replace it here. So we'll say, oops, CDK stack props, and then here props will be CDK stack props. We could probably give it a better name than CDK stack, but just leave that for right now. And then now if we go here, we'll see that we have an error as far as creating our application. It says we're missing our app name. So we can go ahead and say app name, app1. So right now we're not doing anything with the app name, but let's go ahead and create a reusable construct out of this. So let's say we make lots of public S3 buckets in our application. Well, we could create a construct for that and make it reusable, the concept of a public bucket. Just for this contrived example anyway. So let's go ahead and import a couple things here. And then export class, so we'll call it like public bucket, extends CDK dot construct. So let me just copy over our constructor here. We'll basically want to do something very similar to this. And let's define a some props that we can pass into our public bucket, like the name. Trying out these Vim bindings. I'm still getting used to it in VS Code. Let's go ahead and give it like a name for our bucket and make it a required string. And then here we can have our public bucket props, and it should be required. Now we have to call our superclass constructor. It doesn't know anything about public bucket props, so we're just not going to pass any props in. And then if we want our name, we can grab that out of, let's see, do this, name, props. We'll make it public, and then let's give it a proper name. Bucket name. Okay, what happened here? What did I do? Great. So now, instead of creating our bucket here in line, we'll go ahead and use our reusable construct. So we'll say new public bucket, this, pub bucket one, and we can give it some name. So let's call it, for example, app name dash bucket one. And if we want, we can create two of these. Oh, and of course we need to define app name. const name, make props required. And then if we want, we can make multiple of these. So this is the really cool part, is we can go ahead and reuse public bucket. And of course, we can create more and more complex abstract constructs out of our constructs and get fancier and fancier. So if I run this now and I deploy this, first let's take a look at our stack over here. Should hopefully see our CDK stack and our one public bucket here. Great. And we can go see that it deployed here just fine. Now I'm going to go ahead and do another deployment, and it should update this stack hopefully and change it to 2 buckets, each with a customized name. So this is a good intro to CDK. Obviously, you can get much more powerful with it, and there's lots of documentation of different options here. So this describes what you can do with the S3 module, for example. And some of them have more, complex patterns. Some of them are, more simple, straightforward with examples. Documentation is very nice. And there's a lot of other cool stuff we can do. For example, we can write tests for our infrastructure. So here, it's got update in progress. It's currently updating. Let me just jump back and forth here, sorry. And now we can see we have 2 buckets, app bucket 1, app bucket 2, created in our stack. Isn't that cool? And we can go see what the CloudFormation template looks like. Here's our 2 buckets. Pretty cool, pretty cool. Now, as I was saying, we can even write unit tests for our infrastructure. And it's a good little example here. I'm just going to steal this import here real quick. Now, let's say we want to write a test to make sure that we have, one of these buckets is actually being created. So we could say, for example, expect our stack to have resource, and then AWS S3 bucket. And we can give it some expected properties that we hope will be in the output. So for example, I believe we have app bucket 1, right? So we can have app bucket 1 or 2 and expect to find that in our test. So I believe that would be bucket name, app bucket 2. Now, let's say I do a test like this. And here I'm missing the app name. So I can just go ahead and run npm test, nothing too crazy here. And it should fail and tell me that there's no bucket name bucket 3. Right. So it tells us here, bucket name mismatch. And if I want, I can go ahead and change this to bucket 1. And then my test should go ahead and pass. So that's a simplified, overview introduction. Oh, I failed here. Let's see. Test bucket 1, test bucket 2. Oh, it should be test bucket 1, not app bucket 1, because I made my app name test. That's why, of course. So that value should depend on whatever the app name prop was. And there it goes. My test passes. And then once you're done with everything, you can do CDK destroy, similar to how we use serverless framework, for example. And this concludes my presentation. So thanks for watching. Any questions?
I do have one, or multiple. So
yeah, please.
Can I use CDK to access any of those resources, actual SDK actions while in the code, or can I use it just to build infrastructure?
So you mostly use it to build infrastructure. Now, there are some convenience methods for accessing a few resources. Actually, I'll go ahead and share my screen again here. Maybe I can dig up an example. So the documentation is very nice. I recommend, spend a little time with it if you're curious. But for one example that I was using is you can pull in secrets for, so if your stack, if you want to reference an existing secret, you can do that. And you can do it basically like this. You can't reference any old, existing resource, although there are ways to kind of grab them by, let's say, by name, for example. If we look at, S3 bucket, usually there's a there's some ways to refer to existing things. So for example, here you could create from bucket name or from bucket ARN. This will give you a handle to an existing resource. You can't really do stuff like, call dot copy, files to it or whatever. That would be cool. But it doesn't quite go that far, but you can interact with resources that already exist. Again, you can reference a secret ARN or, a secret you define elsewhere in your stack and pull in that secret and use it, as a value in some part of your stack.
Sure, but let's keep using the same infrastructure you already created in your presentation. Can I use can I reference the same S3 without have to install the S3 SDK to use any API from it?
Give me an example of what you would want to do with it.
Let's say I want
I'm not sure I understand.
just to upload a file to S3. I don't want to install the S3 SDK and have to just do, I mean, it's already defined in the CDK, all the name, the region, everything else. I don't want to have to repeat that in my code later. If, have two places pointing to the same, two places in my code pointing to the same place in the cloud.
Well, the usual way I think that's done is with the CloudFormation output. So should be some documentation in here somewhere about that. I forget where in here that it is, but you could define a output that kind of emits a variable, and you can reference that from within your application. So here's a stack with a couple outputs. So for example, there's a table name, and this is the name of a DynamoDB table. So in your application, you can reference a CloudFormation output. You can use the Amazon API to get a CloudFormation value. You can interpolate it in other CloudFormation stacks or in, let's say, serverless framework configuration, stuff like that. You can define the bucket or whatever resource, output the name or the ARN that your application needs to reference it, and then basically import that name. So if my application wants to write to this table, for example, I don't have to copy and paste the name of my table. I can output it in the CloudFormation outputs and then import this into my application one way or another and use that as like the handle to the resource that was created. But I think that's about as fancy as you can get with that.
I think I get it, but I don't know, looks like a missed opportunity to make SDK even better, to just allow me to reference my class and access its API directly.
Yeah, so you're saying something like, do const bucket like this, and then you would be able to say like, sorry, bucket dot, upload file or whatever, like something like this.
Yeah.
You mean?
Exactly.
Yeah, it would be cool. There are certain methods that you can call on some of these resources. It's not quite, like you're describing, but for example, if you were to look at a database, let's see, like RDS, if you want to grant access to a database cluster, you can call a method on it. So here you can actually see methods on database cluster. And I don't remember exactly where the security methods are, but you can call like, cluster.add proxy, for example, and add a new database proxy to it. But again, this is still just for building the CloudFormation. It's not for like runtime, so to say. But yeah, that would be cool. I agree. If you file a feature request, people will read it on their GitHub. Any other questions?
Yeah, so when we create a stack with CDK, we inherit from like the base stack class. So I assume we can deploy like a multi-stack applications with CDK. And the question is when does it make sense to have multiple stacks in an application?
Sure. So, one thing, it's this simple. If you want like 2 stacks, 3 stacks, you can do it like this. And there you go. You have 4 stacks. And you can assign to a variable, of course. So you could say like const app1, or you could say like dev, for example. And if you want to define everything all together, you go const stage. And if you want to, write some custom logic about how they get deployed or when they get deployed, it's TypeScript. You can do things however you want with these constructs. I think it makes sense here. If you want to have different environments, you can pass in account ID, I think, AWS, I forget exactly, maybe it's env account. Yeah, and here you would pass in some AWS account ID and region. So if you want to hard code, like I was saying, different stacks, you can. If you want to split your application up into multiple stacks, but still have it be kind of one unit, you can have, if you have distinct, pretty separate parts of your application that don't have anything to do with each other, you could put them in separate stacks. I'm not sure if there's much advantage to doing that besides keeping the complexity down. There is a limit of how many resources can live in a stack. I forget what the number is. I think it might be something like 200 or 2000. I forget, honestly, but it's not a super high limit. So, it may make sense to split your application up if it gets really big. Maybe you have a lot of lambdas. I think this might be a situation we run into one day as our application gets so big. And if we try making a lambda for each endpoint, that could quickly run into that issue potentially. And you can communicate sort of between your stacks. You can have CloudFormation outputs from one used as inputs to another, like I was talking about earlier. And if they need to reference things in the other stacks, you can totally do that kind of stuff. But I'm not sure what other scenarios you would want to have multiple stacks besides those cases.
So another question I have is when working with like CloudFormation, whether it's like YAML templates or CDK, my biggest fear is like the CloudFormation stack getting clogged up, like in some update or some rollback state. And then like you're basically screwed and you need to like sit and wait for it to time out or whatever. So maybe like it's a more general question, but like what do you do in those situations? Is there any mechanism yet like to prevent that, or I don't know, do something about it?
Well, the good news is that it does add more let's say compile time checks or pre-deployment checks to your application. So for example, normally if you're just writing CloudFormation templates by hand, if you write something that is going to be rejected, you'll get an error. So for example, if you try to put in, an invalid access control, it's going to tell you like, at compile time, like, sorry, that's not a valid access control property. So it does give you some more safety in that area. And furthermore, when you go to actually deploy, it does have a lot of checks that do kind of sanity checks on your template, on your constructs, to make sure that you're, I don't have a good example off the top of my head, but let's say you put in, I don't know, 10,000 gigabytes of RAM for your Docker container. It'll probably not let you deploy that. Like if you wrote that by hand in a CloudFormation template, you would get an error and you'd have to wait for it to roll back and it would, be annoying. Stuff like that can be caught automatically by CDK, and a lot of it is. It doesn't catch everything, and there are plenty of situations where you do something that is valid CDK, that it does validate, but you screwed something up, and you do a deployment, it fails, it rolls back, takes a while, it's annoying, sure. But this does get a bit closer to preventing that for at least like obvious dumb mistakes.
So what are the current limitations of CDK? Why like everyone isn't jumped to use it now?
Well, I think a lot of people just don't know it exists. I think that's one part of it.
Can I add to that
Yeah.
question?
Yeah.
I kind of have something similar. Yep. If I already have an application and I use the SDKs to build my infrastructure, does it make sense to try to go to CDK? Or it's more like if it's a new application, then okay, I use CDK. If not, it's probably not worth to migrate.
That's a good question. I think it depends how your application is set up. So for example, we have a number of applications using serverless, and serverless does some of the same things CDK does. So when you define a function with serverless, it generates CloudFormation for you. It's doing pretty much the same thing as if you were doing that with CDK. And you can do that with CDK. It has some wonderful functions, but for Lambdas where you can actually define like a Node.js or a Python function, which is really cool, but let's not get sidetracked on that right now. So if you're using another tool like Terraform or serverless, it might be trickier to convert.
I don't mean any of those tools. I mean the actually SDKs. Probably what CDK uses behind the curtains.
Well, behind the curtains, it's using the CloudFormation SDK. Yeah, the CloudFormation API.
Yeah, I mean, I can do the same because the SDK already exists for a while. So if I already use that, would be worth to go to CDK to try to rewrite everything to use CDK? Probably, I am guessing so far that it isn't. So that probably one of the reasons most people are not using. Because who actually would care about that tool kind of already have a solution for it?
Yeah, that's possible. I think a lot of people, maybe most, already use some sort of infrastructure as code, like let's say Terraform. I think Terraform is very common. And if you already have your application defined like that, I don't think there's a huge value in switching to CDK. I agree. If you're starting from scratch, I think it's worth playing around with. I built a couple applications for myself with it of varying complexity, and can look at those if anyone's interested. But the complexity of that CloudFormation, that CDK hides for you is pretty nice when you're building a new application, but there are some things that it doesn't solve. So one thing that I'm still not totally sure about is testing locally. So it's great if you want to build your stack and deploy your application with CDK to Amazon, but if you want to run it locally, run your application locally without deploying to Amazon, CDK won't help you with that. Now, Amazon has some other tools that are supposed to play with it. In particular,
that was going to be my next question. Is have you tried to use it with local stack?
I haven't used it with local stack, no. What Amazon pushes is the SAM CLI, the serverless application model, mostly for Lambda, for running like Lambdas locally. And this is how if you want, you can just use CDK and SAM together to run your serverless application on your machine. I don't think it's very mature yet, the integration between them. I mean, you can see here, it's not the nicest thing. You have to stick it in a file and then rewrite it and then execute that's no fun. So I think there's still some way to go before that is as convenient as, serverless framework, for example. So CDK doesn't solve all of your problems by itself. I think it's a piece of, maybe a toolkit that you would use for development, depending on what you're building. If you're just deploying resources, you're not building like a serverless application, it's probably enough on its own. But if you're, building Lambdas and want to run locally like we do, I'm not sure it's quite there yet. And there's a couple plugins for serverless framework, but I tried both of them and it's not a very pleasant experience yet. I think we could eventually ditch serverless framework and just use CDK and SAM, but I don't know if it's quite as convenient yet to do that. I think it will be. But if you want to see, so this is a little application that I was building myself. It has 1 or 2 Lambdas, and it looks something like this. So I have like a Slack webhook secret that I grabbed from Secrets Manager here. And then I have a API gateway. So this lets you create a REST API gateway with cores set up and X-ray tracing enabled. And then you can add like a resource and then attach like a Lambda handler to that resource. So you can say, okay, /sites. If I do a get to /sites, so you can do like sites resource.add method. This is the cool like object-oriented goodies you get with CDK. A Lambda integration using this Node.js function. And this is TypeScript. It'll compile your TypeScript app for you. And you give it the entry point, and that's it. That's how you define like a function, for example, using CDK. So I think it's great for building this, but to your question, Dimitro, it's the local testing is not as convenient, definitely, as it's not as well integrated as serverless framework is yet. But again, this is all just TypeScript code. You can write modules or applications using it or customize it however you want, and I'm sure people will. Maybe we will, who knows? End up building whatever little toolkit on top to make our lives more convenient with it. It's certainly more, it's very extensible, which is what I like about it.
Have you tried to use it for an application that is not serverless?
Yes, I did. So I was trying for a while to deploy Limi, which is, let's see, not sure if I can just Google for it like this, but it's a, what's the word, activity pub? It's a little kind of Reddit clone. Let's see, maybe they have a demo here. It looks like this. It's basically a clone of Reddit. It's written in Rust, and it is made up of a number of Docker containers. So I actually tried to deploy this with CDK. It was rather complicated. Still a lot easier than writing CloudFormation by hand, but it's not serverless. It's actually defining Docker containers that are connected together with load balancer in front. And I can link this if you want to take a look at it. But this is definitely the most complex thing I've done with it. So if you want to see from the top, this is the whole stack, if you want an example. So I create a VPC, I create a database. Now, most of these I define. So database is over here. So this creates a Aurora Postgres serverless database. You can give it, your scaling config and all that. I also create a secret for it. Let's see, I forget where the secret lives. It's not here, but I create a security group. And so I create these little constructs, and then I kind of have that quote unquote outputs as public properties on the class. So this database has, like, for example, a cluster and security group properties. And so my stack, I create a database, and then I can access, like, say, the security group like this. So I can create a bastion host. Now, this is one of the coolest things about CDK, actually, is this bastion pattern. You give it, let's see, what does it look like? It's basically as simple as this. You say bastion host Linux, you give it a security group, and tell it if you want to be in a public subnet. And then you can, define SSH hosts in a key pair. And this generates it'll create an EC2 Linux instance that you can SSH into and use to access your database or anything else in your VPC. Doing this with CloudFormation is an absolute nightmare. It's enormous. It's very unpleasant. So I love this. This is super cool. But what you can do is you can do stuff like database.securitygroup.add ingress rule bastion.securitygroup. And so this lets you, grant access to your bastion host to the database. So I think that stuff's really cool. But the application lives, so I create a load balancer. And so the load balancer is a kind of a complicated application. It has, I think, three target groups. There's a backend, there's a front-end Node.js application, and then there's a thing called iframely, which handles iframing stuff and like a link preview kind of service. So these are three different load balancer target groups. There's I create load balancer listeners. You can do, complex routing on your load balancer like this. If the header is activity pub, then you can tell it to route to the backend, for example. All this kind of cool, fancy stuff. It's pretty verbose, but describes everything that you need. It doesn't really have anything extra. Like it doesn't force you to do a lot of extra work. It's all kind of information that is needed, unfortunately, or whatever. But and then the applications themselves, like the backend looks something like this. Essentially, it's just this. This creates a task definition for a Docker container. So here I'm using this container image from asset, and you just give it a path to a directory. So this is a directory in my system, and it has a Docker file. And so this will actually build that Docker image and then deploy it to Fargate. And then you can, expose a port, give it some environment variables, hook up the CloudWatch logs, all that good stuff. And so, yeah, this is what a non-serverless application can look like. Does that give you kind of a picture? Even generates your JOT secret key here.
And I kind of have another question now. Have you tried to use it with another language that is not TypeScript?
I've only played with TypeScript. Like I said, there's Python, C#, and Java. Also, you can use it with just plain JavaScript if you're, a pervert.
Yeah, sure.
But yeah.
The point of my question was that earlier in the presentation, you mentioned that CDK has some nice features like validating in the compile time some properties, probably not all of them. But isn't that more like a power from TypeScript where you can define those validations in the interfaces and all? While if I was writing Python, maybe I wouldn't have all that.
Yeah, totally. And that's why I use TypeScript. Yeah, absolutely. I mean, you can go, this is what it looks like, for example. This is the Node.js function. You can even just go look at the source and see what it's doing. So, this is, so yeah, one layer of validation obviously is the types. So that's like a nice check. And then there's also the, we could call that a compile time check. And that's these types here, of course. And then there's the, I don't know if you want to call it runtime or compile time. It's compile time of your CDK app, but it's runtime of the, CDK compiler. But, there's some extra checks here. And I assume that these checks are present in, let's say, Python, but the types, maybe there's some type checks, but they're not. I don't know. Maybe it's written, maybe it has full MyPy annotations in the Python app. I'm not sure, but yeah, just use TypeScript and problem solved.
Are there any pricing intricacies when it comes to CDK? Or it doesn't matter what we use to deploy those CloudFormation templates?
Yeah, I'm not aware of any extra pricing that's involved. At the end of the day, it's the same CloudFormation, create stack, update stack API calls. It's not doing anything extra with Amazon, as far as I know. The only thing it does is it creates a CDK toolkit stack for you. And this, I think it just basically shoves your CloudFormation templates in a S3 bucket for you automatically. I think that's all it does, really. So, okay, maybe you pay for that bucket, but I don't think it has any other, extra costs associated with it.